consider the applet above. The graph is in blue, y equal f of x, this. Move the points to construct the slant asymptote for y equal f of x. We're gonna move these 2 points, right? And enter the slant asymptote via its equation here, okay? So recall, the slant asymptote is a line such that the curve gets closer and closer to it as x approaches infinity, right? So perhaps this point should go down here somehow. And as x approaches negative infinity, same idea, right? The asymptote should get closer and closer to the curve. So now a little bit better. Now perhaps even better. Let's move this over here. Little by little, playing around with this applet, you will get to a point in which, look, slant asymptote here, curve getting closer and closer to it as x approaches to infinity, curve getting closer and closer to the slant asymptote as x approaches negative infinity. So I think this is a good way to set our slant asymptote. Now they want you to write out the equation of this slant asymptote, right? That shouldn't be difficult because now we have that the y-intercept is -1, right? -1. So let's start with that. Y equal -1 y-intercept plus the slope. Notice the slope rise over run. Rise is 1. Run is 1 in this particular example, right? So it should be 1, but notice the line is decreasing because if I walk along this line from left to right, I'm going down. So the slope must be negative. So we said rise 1, run 1, but negative slope, right? So this should be the equation of the slant asymptote, right? So -1x, we don't have to write the -1 there. So y equal -1 minus x should be the equation of our slant asymptote.